Newton's first law considered bodies at rest or bodies in motion at a constant velocity. The other state of motion to consider is when an object is moving with a changing velocity, which means a change in the speed and/or the direction of motion. This type of motion is addressed by Newton's second law of motion, which states how force causes changes in motion. This law is used to calculate what happens in situations involving forces and motion, and it shows the mathematical relationship between force, mass, and acceleration. Mathematically, the second law is most often written as net force is equal to mass times acceleration, or the summation of forces is equal to mass times acceleration, where net force, or the summation of forces, is the net external force. M is the mass of the system, and A is the acceleration. Note that the net external force is the sum of all the external forces acting on the system. First, what do we mean by a change in motion? A change in motion is simply a change in velocity. The speed of an object can become slower or faster. The direction in which the object is moving can change, or both of these variables may change. A change in velocity means, by definition, that an acceleration has occurred. Note that acceleration can refer to slowing down or speeding up. Before putting Newton's second law into action, it is important to consider units. The equation net force equals mass times acceleration is used to define the units of force in terms of the three basic units of mass, length, and time. Recall that acceleration has units of length divided by time squared. The SI unit of force is called Newton, abbreviated by N, and is the force needed to accelerate a 1 kilogram system at the rate of 1 meters per second squared. So we have 1 Newton is equal to 1 kilograms times 1 meters per second squared, which can also be written as such. One of the most important applications of Newton's second law is to calculate weight, also known as the gravitational force, which is usually represented mathematically as W. Weight can be represented by a vector because it has a direction. Down is defined as the direction in which gravity pulls, so weight is normally considered a downward force. By using Newton's second law, we can figure out the equation for weight. Consider an object with mass m falling toward Earth. It experiences only the force of gravity, which is represented by W. Newton's second law states that net force is equal to mass times acceleration. Because the only force acting on the object is the gravitational force, we can also say net force is equal to W, or weight. We know that the acceleration of an object due to gravity is g, so we have A is equal to g. Substituting these two expressions into Newton's second law gives weight is equal to mass times gravity. On Earth, gravity is 9.8 meters per second squared, so the weight of a 1 kilogram object on Earth is W is equal to mass times gravity, so that's 1 kilogram times 9.8 meters per second squared equals 9.8 newtons.